My name is Nikita. Have you guys seen my keynote? Yeah, great. So, um, so today on this session, we're gonna go and actually inspect some of the applications I talked about and demonstrate what happens if you put MemSQL as a data backbone to it. So, I myself is an expert in data processing, data management, scalability, and I'm very interested in AI and ML, but I don't build models every day. Though our customers that use MemSQL do that every day, and so I have a good amount of visibility of what happens. So, how many of you work with data? Okay, and how many of you work with big data sets? Right. So what's big, right? So let's test it out. You know, let's say more than 10 million records, more than 100 million records, total. Billion records, 100 billion records. Wow. Yeah, there's some people that are doing pretty crazy stuff. So let me introduce a tool, right? The tool is obviously MemSQL that allow you to, in a very elegant, easy way, deal with large data sets. And here on my laptop, which is this laptop running Linux, I am going to show you a table here using this wonderful tool which we call MemSQL Studio. I'm going to show you a table that has 1.7 billion records. So I'm storing 1.7 billion records on my laptop. How many know what SQL is and how to use SQL? That's very good. That's very convenient. And I always ask this question because usually I get very positive response. So people in general know SQL. And in the data science world, people often start with SQL to pull data into their own tools or frameworks because SQL is so convenient to slice and dice later data before you move it somewhere else. So to level set of what the system is before we go into the actual application, the system is a relational database. It stores data in an incredibly compressed format. So here I'm storing 1.7 billion records on my laptop. The whole thing takes 11 gigabytes. The kind of data here is somewhat typical, right? So data I collected from the telemetry from my own laptop. So I use a tool called sysdig. Kind of looks like this, sysdig, and it starts telling all that information, telemetry that is happening in my own laptop. All the system calls, temperature, all the various telemetry and data points and events that are happening on my laptop. So obviously you can run machine learning models to start predicting of what's going to happen next. And there are startups in San Francisco that are doing exactly that for monitoring, very large data centers, for monitoring Kubernetes containers and whatnot. So I captured that data, and I captured that data in MemSQL, loaded it, and the trick is that you can load that data in real time. So you can connect to anything that emits data. You can connect to stream processing systems like Kafka. Anybody familiar with Kafka? Great. And the data will just start flowing into MemSQL, and you can assume that MemSQL is completely limitless, right? So you can land as much data in MemSQL as you want. Now, but the data is not just stored in some sort of cold storage. If you want to get an individual data point out of the data, you can retrieve that data in an incredibly fast way. So those who worked with S3, Hadoop, yes, yeah, know that if you want to take one individual record stored on HDFS in a Parquet file and you want to get it back, like some sort of big gears need to shift before you get this record back. Well, in this case, let's just try to fetch a record here out of MemSQL on my laptop. Yeah, I can put limit 1 to get 1 record. And stuff comes back in 2 milliseconds. And what that means is you can actually, once you deploy those models, right, and then when you deploy models into production, usually it's the combination of intelligence that's delivered through a model and somebody that serves data to the application. You put them together and you can achieve incredibly low latencies that eventually deliver to what people recently called smart apps. So that's what MemSQL is. Typically in data science, there are multiple parts of the workflow as you put systems into production. When you need to extract individual data points out of the system, you can do it with incredibly low latency. People do it for fraud detection all the time, right? You swipe a credit card, you need to understand if it's a fraudulent transaction, or you walking into a building, you're doing face recognition. That thing that has to be a real-time system. Or you want to extract data from the system and slice and dice it. And I'll give you an example of that as well. This is, in this query, I'm going to scan the whole 1.7 billion records and understand some basic information. So group those 1.7 billion records by this field that's called TID. And that is actually happening also very, very quickly in 1.2 seconds. In 1.2 seconds, we process the billion records here. So now, why this matters is because the system is incredibly convenient in becoming the backbone of where you want to land data, where you want to do feature engineering, where you want to expose that data set to your team. It's very lightweight. You can run on your laptop, and it's free to run on your laptop. And then you can open up your laptop or put it on the server, put it in the cloud, scale it, and then go from analytics and data science to pixels that are displayed on people's apps, on the website, in an incredibly efficient way. Okay, so far so good? Go ahead. So it's focused on fetching data and updating data. So here, let's go and update something. Right? There's an update statement. I can run it, and it's instant. Right? So and the idea is you can build apps. It's a transactional database. So, and usually when you have apps, you want to insert, update, delete, aggregate, produce reports, deliver analytics back to the application, and we give you basically infinite compute. So, absolutely, yeah. We have mechanism of locking a record, and in fact, we only lock on writes. So you will only have conflict on writes, and reads never take locks. So that makes it incredibly convenient to build apps, because what people hate when apps start to spin. Right? There's a spinning, like a wheel on the app. Very often, when we win business from large companies, the definition of success is no spin. No spin. Go ahead. What's the drawback? Well, humbly, there are no drawbacks. So I think the only drawback is that it is in fact a distributed system. So you need to use a distributed system versus sometimes the workloads are such that they fit on a small system, and if they fit on a small system, it's no better, right? So you're kind of wasting that ability to scale. Go ahead. Workflow, the one that I showed on the keynote. Is that what you mean? This one? Yes? Do you build a model in the workflow? Okay, so let's talk about it. So the question is, okay, well, MemSQL is a piece. Yeah, so what's the workflow? And when do you build a model? So typically, this is kind of a very high-level definition of the workflow. You define machine learning use cases. Is there a laser here? Oh, yeah, you define ML use cases. You do some data explorations. So, you don't need a MemSQL to define ML use cases. But when you want to do data exploration, typically people want to play with the data, right? And once you push data into MemSQL, it's very, very efficient. You can explore data yourself by running SQL statements directly against the database. You can attach a BI tool. Now you can visualize it. You can attach a notebook. Now you will be pulling data into Python or Spark, and we integrate and work with Spark incredibly well. So you can play with the data. Now, Scala, PySpark. What? The connector is it's on GitHub, so you download the MemSQL connector, and what we do is we give you very fast data exchange between MemSQL and Spark data frames, and that's what people use all the time. Where MemSQL gives you basically storage and compute with SQL, and Spark gives you training and ad hoc analysis, ETL, feature engineering. And what people do is they create data frame and they call save to MemSQL on the data frame, and the data drops in there and it's reliable, transactional, all these good things. Data pipeline. So, everywhere I go into modern organization, there are data pipelines. You take data extracted from multiple systems, and oftentimes people use Spark. Sophisticated customers, and some of them are here in Israel, use change data capture tools when they pull data from relational databases, MySQL, Oracle, massage the data and push it into MemSQL. So we spend years and put a lot of work into making that process very, very simple. All right. And one of the most common patterns is data pipelines. Usually there's Kafka somewhere, and once data is in Kafka, you can put in data into MemSQL is a click of a button. You say create pipeline, point at Kafka, data is flowing in. Build ML model. So this is what you're going to do with, using Python packages, and then people iterate, right? So when you obviously there's a lot going on when you develop a model, and you think about a million things, but once you kind of out and proud with the model, you want to present results, and you want to deploy that model. And typically, you deploy a model, and then you run in some sort of parallel environment to make sure that you don't screw up. And really, depending on the use case, right? In some cases, the bar for quality is low, and we have some customers that perform fraud detection on electricity IoT data, such that this household spent more electricity than last month. Okay, we want to look at that, right? Well, that's not very sophisticated. And then anything you do there will improve their quality of fraud detection dramatically. And then we have customers that do financial analysis, risk analysis, understanding risk of an individual loan. That's where the bar is very, very high, because you improve the model by a little bit, and then you're saving millions of dollars. Then you plan for deployment, and then you operationalize the model. And so that's where some people deconstruct that model. And let's say they do image recognition, and I showed you that video in the keynote. Maybe I'll show that again here. So in this video, you can point a smartphone at anything, and it will go and find that item in the catalog. So it does it in a very, very fluid way, and it allows people to like compare prices, efficiently shop, or you're talking to a friend and you want to buy the same thing that the friend has and whatnot. So in this case, they took a model and they deconstructed that model, and they expressed that model in feature vectors. And use basic operations that we offer in MemSQL, such as vector.product, Euclidean distance, to run a very simple query. These are the primitive operations that we offer in MemSQL. So if you store feature vectors in a table, now using a scale-out kind of limitless compute, you can run a query that will scan all the records in that table, compute dot product against the feature vector which you got from an image, with all the feature vectors are already there, and if why is it frozen? Well, I'm not going to explain you what a dot product is, but basically running that query where all the feature vectors are greater than 0.9, that's your similarity search. Now, the advantage of doing this in a database is that the actual model, in this case, incredibly primitive, but collocating that the model and the data opens up all the possibilities that you can do. And now what we're working on now is the ability to push TensorFlow and Caffe and PyTorch models directly into MemSQL. And with that, you're able to run those models in production, inside the database, right next to the data, and deliver kind of great user experiences by building smart apps. So I have a couple of minutes left, and I'm happy to answer questions. Go ahead. Hundreds of partitions in Kafka, Spark, MemSQL. Yeah. Very good question. So every operation is, so the way transactions work in MemSQL as a transactional system, everything that's between begin transaction and commit is atomic. So with Spark, it's no difference. If you take a data frame and you say save to MemSQL, this data frame drops into MemSQL in a transactional way. All right, so until every record makes it from that data frame, makes it into MemSQL, nobody else sees that data. There are transaction boundaries around save to MemSQL. In the case of Kafka, we go microbatch to microbatch, and the transaction boundaries are around the microbatch. Multiple partitions. Yeah, multiple partitions. And in fact, if there's a failure, right, then if a so we will never persist half of a microbatch. So each microbatch is going to be delivered to MemSQL as a whole, which gives you exactly one semantics from Kafka. So I'll count until 7. Any more questions? Go ahead. Yeah, training is done outside of MemSQL. So we do not support training, but we can be the data backbone for training. And if training needs data and queries MemSQL periodically, that's a perfect low latency solution for that. All right, thank you.